Great. In this problem, these are ball joints, so they can rotate. So this bar, OA, is rotating with omega 3 rad per second, alpha 0. So it's rotating with constant velocity, let's say by a DC motor. And then this would slide through this slot. So it would slide through this bar. At this moment, when theta is, for example, 45 or whatever, we want to calculate omega of AB and alpha of AB. So we don't write the numerical value. So, but we want to see how to solve this. Let's first strategize. You see, this is one rigid body, and this is another rigid body. The whole thing is not a rigid body because it moves, these two bars move with respect to each other. But this point A is the connecting point, meaning that point A belongs to two rigid bodies, two separate rigid bodies. So this is the point that we can jump from one rigid body to the other one. If we solve one of the rigid body, I mean, in terms of the angular acceleration, angular velocity, and everything, then we can find velocity and acceleration of point A, and that A is on this rigid body as well. So we can use that fact. So we see that we can find the velocity and acceleration of point A because everything about this bar is known, because the angular velocity and angular acceleration is known, and the velocity and acceleration of one point is also known. So the whole thing for the rigid body is known. Now that point A is known, but what else? Well, we see that it is restricted to move along, this bar. But it is not A and C, they don't sit on the same rigid body. We can think of a coordinate system that it is attached to C. Let's say it is welded to C. Then that coordinate system that rotates with C, it sees A going just along that line, along constant line. So I can say that I can attach a coordinate system like that, all right? And then it would be along just the x direction. The motion of A in the eyes of somebody who is sitting at C and it is attached to that C, rotate with that C. So it sees that the A is going just along that direction. But we prefer to use regular coordinate system. Why? Because I and j of this one would be the same as I and j of this one at this moment. And it makes calculation easier. So you can imagine that I attach a coordinate. I imagine that I have this coordinate system attached to C, welded to C. Then I see that velocity of A is along that direction, always along that direction. All right. So now, first we find velocity of A and acceleration of A from that rigid body. Velocity of A equals to velocity of O plus omega plus OA, right? So this is 0. Let's put it there. Zero plus omega, which is 3 rad, 3 k hat, plus OA would be, let's say, I know the length. Let's say length OA. Let's call this one L. So I would say L cosine theta I hat plus L sine theta j hat. So I get, because I know theta, I find VA. AA I find the numerical value. If I know theta, for example, 45, I plug it in there and I know L is, for example, zero point 0.5, then I find everything about velocity of A, the numerical value. Acceleration of A equals to acceleration of O plus alpha cross OA minus omega square OA. Again, it is in fact omega cross OA, but because we are dealing with two-dimensional problem, I can write it as omega negative magnitude of omega square vector OA. This is zero. We say that it is alpha is zero, AO is zero, so both terms are zero. Then I would get negative 9, again, OA, L cosine 30, cosine theta, I hat plus L sine theta, J hat. So I know the acceleration of A and velocity of A. Now let's look at from the eye of that C, that coordinate system that it is welded at C, an observer that it is attached to that point C with this slide, all right? Then velocity of A would be velocity of C plus VREL. I call it VREL, relative velocity. This is that velocity that an observer sitting at C observes, measures. It's like you are assume that C and A are both sitting on a train and the train is moving and stuff, but somebody is coming toward that person A. Both of them are on the same train. So this velocity is the velocity that observer C is measuring, that person C is measuring, that person A is coming toward him. Both of them are on the train. This is that velocity plus omega, this time omega of that bar AB cross CA. In fact, omega of AB and omega of that bar is the same. Omega that you can think of attaching a coordinate system at A and C is going away, or you can attach a coordinate C and it, both this C and this bar, because they are on the same line, right? Even though it is slides, so the omega would be the same and alpha would be the same. So now we know VA. VC is 0. This is with respect to stationary coordinate system now. Everything is with respect to that. So VREL, we know the direction is along that line. So let's call this beta. We know that VA, we know everything about that. We just plug it in there, that number, right? It is K hat cross I hat, which is J hat, K hat cross J hat, which is I hat. So it is negative I hat. So it is negative VL sine theta I hat plus 3L cosine theta J hat equals to VREL. We don't know the magnitude, but we know the direction. So I know I put VREL, the magnitude, and the direction would be cosine negative. Let's say I pick this vector. I can pick this vector as well. Either this vector or this vector. If VREL would be positive at the end, it means that, well, it was along that line. If I pick this line, this direction, and then VREL becomes negative, it means that it was along that line. So it doesn't matter as long as I'm along that line. So I would pick this one. It would be negative cosine beta I hat plus sine beta j hat plus omega k hat, omega AB k hat, plus CA, vector CA. Let's say I'm saying that this is magnitude CA. Again, it would be negative CA cosine beta I hat plus CA magnitude sine beta j hat. And then I equate both sides in terms of I and J, and I find VREL and omega AB because I get two equations for I component and for J component. I post the numerical values uh, under the video on YouTube. So now for the acceleration, we do the same thing. AA equals to, this time I would have AC plus AREL plus alpha, this is alpha of AB, cross CA minus omega squared, omega AB, CA. This is in fact, again, omega cross CA, but because it is two-dimensional problem, I can write it this way. And I have plus 2 omega cross VREL. And this omega, let me write the last term here. So in this equation now, again, like before, I have two components, I and J. AA, we already found, right? We found everything about that AA. This is 0. Then AREL, we know the direction, again, like before. I can write it as AREL, the magnitude, and this direction. So I would have one unknown here. Then alpha, we know that it is in K direction, but we don't know the magnitude. So one unknown here. This we already found, assuming that we solved this for I and J component and we found this. And again, VREL was found and omega was also found. So I would have two equations in I and J component and then two unknowns. The magnitude of AREL and the magnitude of alpha. So in this problem, we need some geometry as well. Let's say theta is given and L is given, this OA. And also, let's say another constant in our problem is the distance between these two bases. Let's call this L2. Then I know at this instant, AC square, the magnitude of AC square, the magnitude of AC equals to L squared plus L2 squared minus 2L L2 cosine theta. So at this moment that we know theta and L2 are given, so we can find AC. When we find AC, we can use sine rule and we would say AC over sine of, or let's say the other way around. So let's put sine of sine of theta over AC equals to sine of beta over L. So we get sine of beta, right? Sine of beta equals to L over AC sine of theta. So in other words, if we know theta, L2 and L, we know this triangle and every geometric value can be found, including sine of beta and the length AC, which we need CA or AC, and also sine of beta uh, and cosine of beta. So everything can be found from geometry, all right?